Okay, everybody, this is the last video in your first unit. This is a lesson on segments and segment measure. So we're moving away from angles and looking at segments now. Really, we've just got two things to talk about. One is called the segment addition postulate. That's exactly what it sounds like, taking segments, adding them together to make a postulate, which is like a rule to follow. And I've kind of just simplified it down to this. Segment addition postulate says part of a line, a segment, plus another part of a line, another segment, equals the whole piece. Part plus part makes whole. Let's see what I'm talking about with some very basic examples. Here we've got the entire segment JL. That's the whole thing. So 128 represents the whole line. Then we've got two parts here. 36 is a part, and some unknown measure is a part. So we've got JK and KL, and then the whole piece is JL. So to follow the segment addition postulate, we would just say part 36 plus the unknown part equals 128. Now you may have already figured this out because you would say if the whole thing is 128, Miss Denton, and I've already used up 36 over here, all I have to do is subtract to find that missing value. And you are exactly right. That is all you have to do. Algebraically, to solve for something unknown, we'd get it by itself, which means we'd just be subtracting that 36. So here I'm just showing my work, but you probably already know how to do this. So 128, take away this part of 36 would leave us with 92. Maybe that's 92 inches or 92 centimeters or 92 millimeters or 92 miles. I don't know. We don't have any units here. Let's try another one. Here we've got the whole piece from G all the way down to D. And it looks like we've got three parts. This part here is 2 units long. F to E is another part that's 12 units long. And then we've got E to D, which is a third part. So the segment addition postulate could expand. In this case, it's going to be part 1 plus part 2 plus part 3 all added together makes the whole length of 21. So 2 plus 12 plus some unknown value is going to equal 21. Well, 2 plus 12 is 14, combining like terms. So we'd have 14 plus something makes 21. Maybe you can do that in your head. Maybe you've already figured it out. Maybe you need the algebra to set it up. If I want to know this unknown value, I need to move over the 14 by subtracting. So 21, take away 14 is 7. E to D is 7. Put our little question mark there. So this was the segment addition postulate extended to 3 parts. Here in this third picture, there's a lot going on, layers of measurement. So we really got to look for what we're being asked. Here we're looking for segment HI's length. So I'm going to put my question mark here. So 4 represents from F to H. 12 represents from G all the way to I. So we may have some unnecessary information here. If I'm looking for H to I, and I know from G to I is 12, then it seems like this 4 is unnecessary. I'm going to take that out. In fact, I don't even need this little piece of segment FG. Given this whole piece, 12, and these 2 parts, 1 and the unknown, I can find HI. If the whole thing is 12 and the small part is 1, what's left over for HI? Maybe you can do that in your head. If you want to follow the segment addition postulate, it would look like this. Part number 1 plus part number 2 equals the whole piece. So 1 plus the unknown equals 12. Subtract, and we get that the unknown is 11. Okay, that was the very basic level there. You may have another technique to tackle those questions. Maybe you don't need to get into this detailed work. However, we're about to vamp it up with some algebra, and you need a technique. So here we're given the same concepts, 2 parts and a whole, but it's loaded with algebra. 3x plus 2 is a part, another 3x plus 2 is a part, and 22 is the whole length. So if I set this algebraic expression up using my segment addition postulate, the equation is going to say part number 1, which is 3x plus 2, plus part number 2, which is 3x plus 2, makes the whole length of 22. Pause here and solve for x. In solving for x, I get 3. First, I combined like terms, then I moved over the 4, and then I divided away the 6 to get 3. Try it on number 5. Set up your equation and solve for x. Okay, let's see how you did. If I'm following the segment addition postulate, then part plus part equals whole. So my first part is 2x plus 26, the second part is 4, and the whole length is x plus 20. So here's my equation, 2x plus 26 plus 4 equals x plus 20. In solving for x, there's a lot of combining like terms, moving all the variables to one side, moving all the numbers to the opposite side to complete the solve, and I get x equals a negative 10. Everyone, it is okay for your variable to equal a negative number. I know you may have felt like you did something wrong, but you actually haven't. The only time to be concerned is if you were to take that negative value and plug it back in, you have to check and make sure you're getting all positive values. Let's plug this back into the whole. Negative 10 plus 20. Negative 10 plus 20 is 10. So I still get a positive length. I still get a positive value when I plug it back in, which means this is a good answer. Okay, last but not least, we're going to move on to the highest level here. We're going to start with the geometry, apply the algebra, and then bring it back to geometry by finding unknown lengths. Use the segment addition postulate and set up an equation that will solve for x. Okay, let's check out your setup first. Following the segment addition postulate, the 2 parts add together to make the whole. So my equation says 10 plus x plus 1 equals the whole length 3x minus 1. Completing my algebra, I get 6 equals x. Now we've gone from a geometric concept, the segment addition postulate, we've applied the algebra skills to solve for x, and now we're going to work back into the geometry by using the 6 to find the unknown value. So take a look at KL. KL is x plus 1, but we know that x is 6. So if we replace the x with the 6, we'll get 6 plus 1, which is 7. So KL is 7. We can apply the same technique to find JL. JL is listed as 3x minus 1. Replace the x with the 6. would make 3 times 6, 18, and 18 minus 1 is 17. You can do a real simple check here now. Is JK 10 plus KL's 7 equal to the whole length 17? 10 plus 7 is 17. So that's a quick check to make sure you've done that work right. Okay, let's flip over to the back and see what else we've got. Okay, on this side, we're really focusing in on the concept of congruent segments. We have talked about congruent angles a lot, but now we're going to focus in on congruent segments. Congruent segments are segments of the same length. In order to have the same length, they must have a point that's right smack dab in the middle. We call that a midpoint. A midpoint is a point that is exactly in the middle of a segment. So if your picture has a midpoint, then the two parts are now equal to each other because we have congruent segments. I've put a reminder bubble here that the symbolism for congruent segments is these little hash marks included in the picture. So these little tick marks on the line tell us that segment LM is congruent to segment NM, which makes M, this point in the middle, the midpoint. Let's check out an example. Okay. Oh, gotta adjust just a little more. There we go. All right, let's all look at number 1 together. We definitely have the congruent symbols on our line segment here, which means segment AB is congruent to segment BC. I think I'll jot that down just for practice. AB segment is congruent to BC segment. What that also means is that B is a midpoint. It's important to start to recognize vocabulary. Point B is the midpoint of this segment. If we have a midpoint, then we have congruent parts. We have two equal values. So my algebra is going to set up to say that the part on the left, negative 7 plus 3x, is equal to the part on the right, x plus 5. These two values are equal to each other. Take a moment and solve for x. When solving for x, I get x equals 6. We had variables on both sides that needed to be moved. We had numbers on both sides that needed to be moved. So just be careful with all the moving of values. Let's move forward. If x equals 6, look at what we're asked for. We're asked for the length of segment AB, the length of segment BC, and the length of segment AC. So find the appropriate algebraic expression to plug in for. If we need to find AB, it's marked as negative 7 plus 3x. We're now substituting 6 in for x. So this will be negative 7 plus 3 times 6. Well, 3 times 6 is 18, and 18 take away 7 is 11. So the length from A to B is 11. I'm going to write that up here. Now let's check out BC. BC is listed as x plus 5. So if BC is x plus 5, and we're substituting 6 in for x, that becomes 6 plus 5, which makes 11. 6 plus 5 is 11. Now, does that make sense? That both sides are 11? Hopefully so, because B is a midpoint, which is right in the middle. If both pieces are 11, from A to B is 11, and from B to C is 11, then now we can use the segment addition postulate to find AC. Part plus part equals the whole piece from A to C. And 11 plus 11 is 22. Pretty cool. One more to go, everybody. I'm going to help you think through the beginning of this one, and then I'm going to let you roll. In this second example, we've been given the whole length as 78. So I'm going to go ahead and copy that down in AC down below. That's 78. We've also been told that these segments are equal, which means B is a midpoint again. Which means B is right in the middle, splitting 78 in half. So 78, do a little math over here, 78 divided by 2 is 39. So BC is 39 and AB is 39. So I already know the answer to these two blanks. They're both going to be 39. So we're kind of working this one backwards. If each piece is 39, now I know what to do with my algebra. This 5x minus 6 is listed as AB, and now we know that AB is 39, so the algebra can read 5x minus 6 is 39. Take a moment and solve for x. In solving for x, I got x equals 9. Thank you for all your hard work on this lesson. Good luck with the practice, and come see me if you have any questions.